Hello and welcome to another EE140 video. Today we're going to attempt to solve question number 2 from our midterm 2 last Thursday. So let's begin. So we're given a 1592 megahertz LHCP wave that is observed to have a magnetic field or H field of 5 milliamps along the y direction when t equals 0. We're also given a wave propagation vector given by this function. Now we are tasked to find the full time domain expression of E field. So remember we're going to have two terms because it's circularly polarized. All right, so first let's figure out our omega. And omega is just going to be 2 pi times our frequency, which is 1592 times 10 to the 6. And that just comes out as 1 times 10 to the 10, or just 10 to the 10. Now we have our omega. Let's figure out our magnitude for our k, because we're going to need it. So k naught is going to be square root of 40 squared plus 30 squared, coming from here. That is just root of 2500. That just comes out as 50. So now that we have our k naught and omega, we could calculate for our n. We're not sure yet if this wave is traveling in air, so it'd be a good practice to check. So we have omega over k naught equals nu. That is equals to c over n. So we're trying to check if our n is just 1 or something else. So for n is just going to be equals to c, which is the speed of light, times k naught over omega. That is 3 times 10 to the 8 times 50, or k naught, all over 10 to the 10. And from here, we could get that n is 1.5, so it's not traveling in air, but something else that has an n equals to 1.5. So now that we have those things, we could draw our axes. K, that is 40x negative 30z, so that's going to be along the fourth quadrant. It's going to be over here. So this is our k vector, and this is just going to be 30. This one's going to be 40. So let's label this. So this is going to be x, this is going to be z. And using our right hand rule for axes, we determine that positive y is going into the page and negative y is coming out of the page. So with that, we could write down that our h is going into the page as well. So now we could use our right hand rule to determine which direction or which quadrant the E field or E1 is going to fall into. So with K as our thumb, right thumb, and H as our right curl fingers. So once we have our thumb along this direction, all right, and we have the curl of our fingers pointing into the page, once we uncurl those fingers, it's going to point out this way, right? So that is going to be our E1, which is just our right fingers straight up. But what about our ratio? So here it's a 4 to 3 ratio. Over here for our E field, it's going to be 3 to 4 ratio. So this one's going to be 40, this is going to be 30. So our direction for our E1 t equals 0 is going to be negative 30 x hat negative 40 z hat. I'm sorry. Right? Now that we have our direction, we could figure out our magnitude for this relationship. E naught over H naught equals eta. And eta is equals to eta naught divided by n. And since we have our n here, we could easily solve for that. So that's going to be 377 divided by 1.5. This one just comes out to 251.33. Now we're going to solve for E naught, right? Because we need the magnitude for E naught or for E1. So E naught is just going to be the magnitude of H, which is 5 milliamps per meter. So that's going to be H naught times eta, which is the same as 5 times 251.33. That just comes out as 1256.67. Magnitude, which is 1256.67. And since this is t equals 0 and we're getting a non-zero, so we could assume that this is a cosine function. Then plug in our omega t. Now, is it going to be minus or plus? Since we're given positive here for x, that's going to be negative 40x plus 30z. So that is for our E1. Now remember we have two terms because this is a circular polarized wave. So now we could figure out, or we could solve for our E2. For E2, we draw our axis again. That way it's not messy. And we know that negative y is coming out of the page. Y is just into the page. We have our k vector fourth quadrant over here. And we have our E1 on the third quadrant over here. So this one's E1, this one's K. Now we are told that this is a left-hand circularly polarized wave. So now we are going to use our left hand. So with K as our left thumb, E1 is just our left fingers. If we position our hand going this, or our thumb going this way, and just our fingers flat going this way, once we curl that, it's gonna be so pointing out at the page, right? Thumb towards the fourth quadrant, fingers towards the third quadrant, and then using our left hand, we curl it. It's gonna be coming out at the page. So we could say that E2 is coming out of the page. So therefore E2 will have a negative y direction. So here we could write negative y hat. Now the magnitude is just going to be the same, 1256.67. Now 90 degrees in phase with cosine, that's going to be sine. And that's going to be 10 to the 10th for our omega. and it's still going to be the same k. So negative 40 x plus 30 z. Now all we need to do is just combine the two. So our full time domain expression for our E field is going to be, and do not forget our unit since we came from milliamps per meter, this is going to be millivolts per meter. Full time domain expression of our E field wave. I hope this video was clear enough for you. Thank you for watching and have a great day.